All right, let's see what we can do with this practice test for our radicals test. Keep a few things in mind here first. Number one, if there's a perfect square, take it. Number two, if there's a fraction, reduce it. And third, if you can simplify a radical, do it. Let's look at number one. All we're doing here is simplifying this radical. All right, so radical 50. We've done this enough times. We should know that that's going to be a 5 outside the radical and 2 inside the radical. The x to the third, there's going to be an x outside and there's going to be an x inside. The square root of y to the fourth is y squared, so we're going to have 5x y squared radical 2x. Number two, take the square root of 36. It's 6. Take the square root of x squared. It's x. The square root of y to the eighth, y to the fourth, 6x y to the fourth. Number three, numbers underneath the radical, multiply them. Radical 81. What's the square root of 81? 9. 4 radical 3 minus 5 radical 27. Can't we simplify the radical 27? So I'm going to have 4 radical 3 minus 5. Now, what's radical 27? Well, that's going to be times 3 radical 3. These two numbers get multiplied, so we're going to have 4 radical 3 minus 15 radical 3. Since we have like terms, 4 minus 15, negative 11 radical 3. In number 5, radical 2 can't be simplified. Radical 3 can't be simplified. I don't have any perfect squares. I can't reduce the fraction 2/3, so I'm going to have to rationalize the denominator here. I'm going to multiply by radical 3 over radical 3. Keep in mind, you have two different parts of the problem here. You have a numerator. What's in it? Radical 6. You have a denominator. What's in it? Radical 3 times radical 3 is radical 9. The square root of 9 is 3. Radical 6 over 3. In number 6, can we simplify radical 2x? No, you cannot. So what are we going to do here? Well, it says we need to subtract. Well, in this case, we're going to be subtracting the coefficients 4 and 1. 4 minus 1 is 3. 3 radical 2x. In number 7, you might be thinking that we're going to be using the distributive property, and we probably are. But I see a radical 5, I see a radical 6, and I see this radical 8. It can be simplified. So before I do any distributive property, I'm going to be taking 3 radical 5 times the quantity, 2 radical 6 minus, what's radical 8? 2 radical 2. Now I'm going to distribute. I'm going to be taking 3 radical 5 times 2 radical 6. Now what I would do is actually write that out. 3 radical 5 times 2 radical 6. And what is that? Multiply the numbers outside. What do you get? 6. Multiply the numbers inside. Radical 30. Can that be simplified? No. I'm going to bring down the minus sign. I'm going to be making the 3 radical 5 times 2 radical 2. I'm going to be making that into what? 3 times 2 is 6. Radical 5 times radical 2 is radical 10. Your answer is 6 radical 30 minus 6 radical 10. In number 8, 6 radical 2 plus 4 times the quantity 3 radical 6 plus 5. I'm thinking window panes here. Because I have a binomial times a binomial, I'm going to be using window panes. And to do that, I'm going to be taking 6 radical 2, putting it on top, 4 here, 3 radical 6 on the side, and radical 5 here. Multiply these two, for this first square, I'm going to be taking 6 radical 2 times 3 radical 6. 6 times 3 is 18 times radical 12. What's radical 12? 2 radical 3. So I'm going to have 18 times 2 radical 3. 18 times 2 is 36 radical 3. Then I'm going to be taking 4 times 3 radical 6. That's 12 radical 6. Then I'm going to be taking 6 radical 2 times radical 5. 6 stays on the outside. Radical 2 times radical 5 is radical 10 plus 6 radical 10. And then I'm going to be taking 4 times radical 5, and I'm just getting 4 radical 5. Now at this point we would want to add like terms, but I only have a radical 3, radical 6, radical 10, and radical 5. None of those can be combined. They're all simplified, so my final answer is simply these 4 terms. 3 plus radical 7 squared means 3 plus radical 7 times 3 plus radical 7. This is another window panes. 3 plus radical 7, and then 3 plus radical 7 again. 3 times 3 is 9. I'm going to go ahead and go down to the bottom right. Radical 7 times radical 7 is 7. Up here in the top right, I'm going to have 3 radical 7. In the bottom left, I'm going to have 3 radical 7. I'm going to be combining like terms. The 9 and the 7 are going to be added together, and I'm going to get 16. Plus, I'm going to add these radical 7s together. 3 radical 7 plus 3 radical 7 is 6 radical 7. 16 plus 6 radical 7. In number 10, again, I have a binomial times a binomial. This is going to be another window panes. Radical 2, radical 5. Here's my radical 2, but this last one is negative radical 5. Top left, radical 2 times radical 2 is 2. Bottom right, radical 5 times negative radical 5. Well, if it were radical 5 times radical 5, we'd have 5. But I have radical 5 times negative radical 5 is negative 5. In the top right, radical 10. In the bottom left, negative radical 10. The 2 minus 5 gets combined. 2 minus 5 is negative 3. Negative radical 10 plus radical 10 is 0. They cancel out. Your answer is negative 3. Find the distance between the 2 points. Well, do you remember the distance formula? You're supposed to have written it down every time we worked on this problem before. So we're going to have the square root of the quantity x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So without the x's and the y's in here, it would look like this. I have a parentheses, a minus sign, parentheses closed, plus, and then square it. A parentheses minus, parentheses closed, and square that. Now, what are the numbers that go in here? Well, the x2 is this x here, negative 5 minus 4. And then the y's, I'm going to be taking 2 minus the 5. Let's figure this out. Negative 5 minus 4 is negative 9. Negative 9 squared is 81. Plus 2 minus 5 is negative 3. Negative 3 squared is positive 9. So I'm talking about the square root of 90. Simplifying this, we have 3 radical 10. Page 2, we're solving equations here. So what do we do first? Remember the steps? Isolate the radical, meaning if there are any numbers outside the radical, get rid of those first. The 5 is outside the radical. To get it to the other side of the equal sign, subtract 5 from both sides. Radical 2x plus 4 is equal to negative 2. What's telling us right now, class, that this is going to be a no solution? The fact that we can never take the square root of a number and get a negative 2, so we're going to have no solution. Number 13, isolate the radical. There are no numbers outside the radical on the left side of the equal sign. Number 2, square both sides. So I squared this, I get x plus 5 is equal to 49. Solve. Subtract 5 from both sides, you get x is equal to 44. Number 14, there's no numbers outside the radical. Square both sides. We get 5x plus 26 is equal to 4 times 4 is 16. I'm going to subtract 26 from both sides and get 5x is equal to negative 10. X equals negative 2. Number 15, square both sides. I get 5x plus 14 is equal to 49. Subtract 14 from both sides. I'll get 5x is equal to 35. X equals 7. Evaluate 4 to the 3/2 power. So we get your calculator out and we type in 4. Use the caret key to raise it to a power. We're going to do 3 fraction 2, 3 over 2, and that shows us 4 to raise to the 3/2 power. Press enter and we get 8. So our answer to number 16 is 8. However, on number 17, when I take 5 to the 4/3 power, so I try 5, I raise it to the 4/3 power, and I get this ugly decimal, 8.54 whatever, right? That means this one's not going to be able to be simplified as simply. So what we have to do is simply remember that the numerator is the inside number. It's the exponent. The 3 is the outside number. It's the root. So we're going to have the cube root of 5 to the 4th power. Well, the cube root of 5 to the 4th, I'm going to need 4 5s here. For every 3 identical factors underneath, I get to pull 1 out. And I have the cube root of 5 left over. So this is read 5 times the cube root of 5. Number 18a, the radical 6y over 5. Can the 6 over 5 be reduced? No, it cannot. So we rationalize the denominator. Multiply by radical 5 over radical 5. In the numerator, we have radical 30y. In the denominator, we have 5. This will be your final answer. And in number 18b, I see a couple of zeros that are going to cancel out, and I'm going to be able to take the square root of x squared. The square root of x squared is x, and I have radical 2 over 3. Rationalize the denominator. Radical 3 over 3, radical 3. And here's what I have in the numerator now. Just look at your numerator. What do we have? An x outside, radical 6 on the inside. What do you have in the denominator? 3. So you have x radical 6 over 3. Good luck on your test, and we'll see you in class next time. Bye.